Welcome, everybody. My name is Masud Husain. I'm co-lead for Dementia Research Oxford with Cornelia van Duijn. And it's a great pleasure for us today to introduce Ivan Koychev, who's our colleague and consultant neuropsychiatrist here at Oxford. Ivan is also senior clinical researcher at the Department of Psychiatry, and he also leads the Great Minds Register at Dementia Platforms UK, which is a cohort of volunteers who are interested in being involved in dementia research. Ivan has a focus on biomarker-based clinical trials, and today he's going to tell us about something really interesting, which is insulin resistance, a potential disease modification pathway in Alzheimer's disease. So please, Ivan, go ahead.
Fantastic. Thank you very much for this opportunity, Masud. It's great to be speaking to this group. So as Masud said, I'm going to speak about my primary interest at the moment is this concept of insulin resistance and whether it has potential, and I'm going to argue that it does as a potential both stratification method, as in determining who is more likely to be developing cognitive impairment in their later life, as well as a potential mechanism for disease modification. Now, diabetes and dementia, this is a well-trodden path, so a lot of research has been done. At the forefront is the observation that type 2 diabetes associates with dementia. In fact, having type 2 diabetes almost doubles the risk for dementia, both vascular, but also Alzheimer's disease. And in effect, a huge proportion, so 7 out of the 50 million people currently living with dementia have comorbid diabetes. Now, you don't have to have diabetes in order to have a negative impact. You don't have to have dementia in order for diabetes to play a negative impact on your cognition. So people in late middle age who have diabetes essentially lose cognition. Here they've done a study using mini mental state examination, so they lose cognitive points faster than the controls. And also in a study that looked at glucose tolerance test, they found that people who had impaired glucose tolerance in middle age, regardless of whether they had diabetes or not formerly, these people were at a high risk of developing dementia 35 years later. And all of this also circles back to the concept of biomarkers. So as you know, we're now thinking of dementia as a biological entity that is confirmable using biomarkers. So there is this ATN framework where A stands for amyloid, T for tau, and N for neurodegeneration. And there is evidence that type 2 diabetes and insulin resistance mediates the risk of people developing biomarker abnormalities along these lines. So again, another longitudinal study shows that if you were diagnosed with type 2 diabetes, then your risk of having a positive amyloid scan 7 years later is higher. Also, people who have type 2 diabetes have a higher level of phosphorylated tau. That's if you like, the tau measure in CSF. And in terms of neurodegeneration, people usually look at typically MRI, so volumetric measures of atrophy, as well as FDG PET. And both of these have been shown to be at a higher rate of abnormality in type 2 diabetes. So both vascular atrophy and specifically in Alzheimer's disease area, as well as hypermetabolism on FDG PET. Now, an important thing that we now know is that the brain is a very insulin sensitive organ. Some time ago, people thought that insulin doesn't cross the blood-brain barrier, but that is not actually the case. And in fact, there's high expression of insulin receptors in the brain. And again, these tend to be in the areas where we expect to see the first damage associated with Alzheimer's disease. Now, in terms of what insulin actually does, there's certainly a role in regulating neuronal function, but also it seems like it's directly involved in the processes that we associate with Alzheimer's disease, so the tau phosphorylation. There are studies that, for example, postmortem studies that show that insulin essentially inclusions in the neuronal body colocalized with neurofibrillary tangle. That's in postmortem tissue. Now, there's also findings that people differ in how their brain reacts to insulin, and these tend to be mediated by obesity, blood-brain instances where the blood-brain barrier has been altered, as well as genetics. And all of this has also been supported by a set of experiments where insulin is delivered directly to the brain. That is through intranasal delivery, and these intranasal experiments have shown that essentially where there is a central insulin acting in the brain, the whole body insulin sensitivity is increased, the eating behavior is regulated, and there is an associated change in hypothalamic blood flow, which has led to people actually developing methods to study central insulin resistance using this particular property, the last one that I mentioned, so the changes in hypothalamic blood flow in response to intranasal insulin. So this is an example, a paper from 2 years ago, where they used essentially cerebral blood flow, and specifically in the hypothalamus, pre and post intranasal insulin, and they took the difference in activity as a proxy for central insulin resistance. And in this particular study, they found that just looking at people who are diabetic, there is some variability in terms of how centrally sensitive their brains are, and this variability, so the more sensitive it is, the more likely they were to sustain weight loss as part of an intervention that was done in the trial. So it looks like how sensitive your brain is quite variable, as in just because you're peripherally insulin resistance doesn't mean that you have central insulin resistance, and this central insulin resistance actually mediates certainly important eating behaviors, but perhaps something else. And that is the first research question that we'll be pursuing. This is with my PhD, Graham Reed, who you can see on the right, where the question that we're asking is whether the central insulin resistance is perhaps mediating the risk that we observe for Alzheimer's disease in type 2 diabetes, and subsequent to this, whether if that is true, whether there is a subgroup of type 2 diabetes that is particularly at risk for Alzheimer's disease based on their brain insulin resistance. And we'll also be asking the questions whether we can rely on scalable biomarkers to monitor the Alzheimer's disease risk in the subgroups that we've identified as particularly at risk. What we're going to be doing is certainly a pilot study to be essentially testing this concept that if you give people intranasal insulin, you can have a sensitive proxy of central insulin sensitivity. The reason why we need to do this is because when we've reviewed the literature, actually it turns out that it's far from certain what measures or even what sequences people should be looking at if they want to have an in vivo measure of central insulin resistance. And then we're going to move on to a study where we are comparing type 2 diabetics and healthy controls, again, using this intranasal MRI experiment. And then we'll be following them up in terms of their cognitive performance using digital technology. The hypothesis being that the people who are more centrally insulin resistant are the people who are more likely to be deteriorating cognitively within 1 to 2 years. Now, the second topic that I would like to talk to you about is if you like if this was about how we stratify risk of cognitive decline in diabetes. The second one is whether this is a potential disease modification pathway, and there is now rich epidemiological data pointing to the newer classes of anti-diabetes drug being protective for dementia. This is the first one that I'd suggest is perhaps the papers to read. This is in 170,000 people from Denmark which compared people who were diagnosed with type 2 diabetes and controls, and then looked at the people who developed dementia versus those that didn't, and then they found that the newer compounds, so DPP-4 inhibitors, GLP-1 receptor agonists, and SGLT2 inhibitors, all associated with significantly reduced risk for dementia, where GLP-1s and SGLT2s were the ones that survived a number of corrections. Now, in this same paper, they also looked at whether the time that you're exposed to one of these compounds also mediates this risk, and they found again that the longer you are on a GLP-1, certainly, as well as DPP-4 inhibitors, the longer you have been exposed, you've been prescribed these medications, the larger the reduction of risk. This is the second paper that I'd say is very informative. This one combined data from three trials of GLP-1 receptor agonists, about 12,000 people in total, and then they looked at the risk of developing new diagnoses of dementia in people who were randomized either to placebo or to GLP-1 receptor agonist, and they saw a significant deviation already at year 2 post-randomization, or actually a year and a half after randomization, and the difference between the two groups widened. They then went on in the same paper to look at 120,000 people who were prescribed type 2 diabetes, where they were able to actually do a head-to-head comparison of GLP-1 receptor agonists versus other second-line treatments for diabetes, and they found out that GLP-1 receptor agonists outperformed the other second-line treatments. Now, in this paper, they also looked at whether there's any particular factors which made it more likely that GLP-1s are going to have a preventative effect, impact in terms of future dementia. And they found that if the age at which the medication is prescribed was under 70 years, then this was significantly favoring dementia prevention, and also whether people had cardiovascular disease also to an extent favored whether people are going to get benefit from GLP-1s. Now, the research question that this led us to was how do GLP-1 receptor agonists interact with Alzheimer's disease pathophysiology? And for this, we applied for an investigator-initiated clinical trial to Novo Nordisk. So I did this together with the Diabetes Trials Unit, so Rory Holman and Amanda Adler. And as you'll see, this involves quite significant imaging capacity. We're collaborating with Paul Edison at Imperial to do this. So the primary goal of the study was to investigate the effect of oral semaglutide, so this is a GLP-1 array, on the accumulation of tau in people who are thought to be in preclinical Alzheimer's disease. So the primary outcome in this case is tau PET. Tau PET is assumed, based on current evidence, to be perhaps the gold standard outcome measure, where you are trying to assess efficacy in preclinical dementia, particularly tau PET in the medial temporal lobe. And preclinical dementia here is defined as being amyloid positive on PET. In this trial, we'll also be looking at the effects of neuroinflammation. The reason for this is because GLP-1 arrays, one of the potential mechanisms in which they could be exercising this effect on Alzheimer's disease pathophysiology is through modulation of neuroinflammation. That's something that's coming from the animal literature. The way we are assessing this is using essentially, again, positron emission tomography, so TSPO PET. We will also be looking at the effect on Alzheimer's disease pathology in plasma. We're taking blood on 7 occasions, and we'll be looking at a number of the well-validated biomarkers of Alzheimer's disease, so p-tau 181, neurofilament light, as well as glial fibrillary activation protein, so GFAP. We'll also be looking at the effect on cognition. Here, we're very cognizant that we're dealing with a preclinical or at most a prodromal population for Alzheimer's disease. And so in addition to the in-clinic testing, which is both computerized as well as pen and paper, we're also collaborating with Adam Hampshire at Imperial in the delivery of remotely delivered cognitive testing, so bursts of testing over 3-day periods, so about half an hour each on 3 consecutive days, so that you are able to look at for example, accelerated forgetfulness, which has been shown to be discriminatory in people who are at risk for dementia. Then we also want to look at the effect on neurodegeneration. This is primarily going to be volumetric MRI, which we do at the same time as the PET scans, and then of course safety, quality of life, as well as levels of activity. So here we are asking people to wear an actigraph for a week at baseline and then at 12 months. This is what the trial looks like. So this is a randomized double-blind placebo-controlled trial, as I said, of oral semaglutide up to 40 milligrams in an escalation that takes 4 weeks to achieve. We have 4 primary sites: Oxford, Imperial, UCL, Bristol, and Exeter. We opened Oxford in August, and the study is going to take 27 months to complete. And the interesting thing is we've had excellent response from people, so individuals who are healthy aging but are very concerned about their future risk of dementia. So we've managed to screen 25 people within a relatively short space of time. This is what the study flow looks like. People attend a screening visit, and then they have PET amyloid in order to only include people who are PET amyloid positive. We plan to randomize 88. This is because we want to get to a sample of 76. We assume about 15% will drop out. And then, as you can see, people are attending a number of visits, and then the study closes at 12 months. The main inclusion criteria is people who are over the age of 55 and amyloid positive. But the other thing that is important is their clinical dementia rating scale has to be 0.5 or below. So for those of you not familiar with the scale, essentially means that they have at most mild cognitive impairments, so some cognitive deficits, but they're not impacting on daily function. Now, an important thing to consider is how would we get these people who are amyloid positive and yet they don't have dementia. We're certainly relying on research-ready cohorts like the Great Minds cohort that Masud mentioned in the beginning. So we're recruiting people either on the basis of a known amyloid status, because in Great Minds we are recruiting people already who have been part of studies. So for some of them, like the EPATH study, we would already have their cerebrospinal fluid data on amyloid and tau, but that is a relative minority. So for the rest of the sample, we are applying a risk stratification method. This relies chiefly on ApoE4 carriership. To avoid disclosure, we're contacting people on the basis of 4 amyloid positive people for every 1 amyloid negative. And in addition to this, we're going for people over the age of 55. Where ApoE4 data is not available, we can recruit on the basis of people having mild cognitive impairment or a combination of cognitive, Alzheimer's disease biomarkers in plasma, and family history of dementia. This is a busy slide, but it really shows you the breadth of phenotyping we're going for in this study. The main ones are at baseline and at 12 months. We're doing tau PET and TSPO PET as well as MRI. We're only doing amyloid PET at baseline. So we decided against testing if semaglutide has an effect on amyloid positivity over the 12 months. This is because, one, there's really no good evidence that that essentially amyloid PET is a good outcome in efficacy trials. Obviously, a number of compounds are being developed specifically targeting amyloid therapy, But as you probably know, neurodegeneration is much more tightly coupled with tau PET as well as hypermetabolism on FDG PET, and less so with amyloid accumulation itself. The other reason why amyloid PET or amyloid wasn't considered a good enough measure is because the link between type 2 diabetes and amyloid tends to be quite controversial. I know that I showed you a study which showed that you run a higher risk of amyloid PET when you have type 2 diabetes. But this is a study from this year from Brain. But prior to this, there was really quite controversial. There were quite conflicting studies on whether you actually have higher chance of being amyloid positive if you have type 2 diabetes. The other things to mention are these type 2 these remote cognitive testing with Cognitron. That's the imperial test that's done at baseline, 6 months and 12 months. These are these clusters of testing over 3 days, as well as a number of studies, a number of scales looking at depression, health anxiety, as well as specifically distress at disclosing future risk of Alzheimer's. Because, as you can imagine, one of the challenges in running these studies is that we are recruiting people who do not have dementia, and we, by definition, are feeding back to them that they're amyloid positive. So even though existing studies have suggested that that is not overly distressing to people, we still consider this to be an important safety safety consideration. So we're regularly recording this data from participants that come to our trial. Now, the questions here that I wanted to pose to this group and see whether anyone has any particular views on this, I'd be very grateful for your thoughts, is whether anyone has had any first-hand experience of what is the optimal in vivo measurement of central insulin resistance. Obviously, we're going down the route of MRI experiments with this intranasal insulin model, but it may not be that is the most appropriate thing. There is again a paper from this year which looked at plasma extracellular vesicles enriched for neuronal origin, and there people have been able to identify a variety of proteins associated with the various stages of the insulin pathway in the brain. And at least in that paper, they seem to claim that it is a sensitive measure of central insulin resistance. So I do wonder when anyone has any experience with that particular methodology and can advise on how achievable that is. And then the other one is just wondering about how to best progress with efficacy studies that are targeting dementia prevention, particularly where we consider using repurposed compounds like GLP-1 receptor agonists. One particular challenge, or more like opportunity, is that for a number of promising compounds, we have biological samples from existing primary clinical trials. And so with the advent of biomarkers of Alzheimer's disease in blood, it is now possible to screen for potential effects, potential disease modification effects. But there is a question of how do you generate a reliable sample size calculation. So if anyone has had any thoughts on that, that will be welcome. Then there's another question about how do you effectively stratify for risk of Alzheimer's disease, and particularly for amyloid positivity. I showed you what we've considered to be effective using genetics, plasma biomarkers, as well as demographic information. But any thoughts on this would be of value. And then finally, studies like ISAP are only recruiting 88, and yet they're extremely expensive and really only within the spending powers of a pharma company like. In this case, our collaborator Novo Nordisk. But if we wanted to take a repurposed compound and test it out of academia, then we really couldn't be testing PET tau and TSPO PET compounds, TSPO PET or tau PET or TSPO PET as an outcome measure, and rather we need to have sensitive, scalable measures So the question to this group, I guess, is whether we're ready to consider blood or digital cognitive testing or even wearables as a suitable efficacy outcome measure in trials where we're trying to detect efficacy in people who are otherwise cognitively healthy. That's what I have for you. These are my acknowledgements. So a number of people have worked on this, and I'm very grateful for them, for their efforts. So yeah, I'll stop sharing, and I'm open to any questions.
Thanks very much, Ivan. I've opened the chat up for people to write any comments or questions they have for you, but maybe I could start off and take you back a bit, because these glucagon-like peptide 1 agonists, the GLP-1 agonists, a question that must be going through everyone's mind is, what about the diabetic control and risk of dementia? Central insulin resistance is one aspect, right? But is it the fact that GLP-1 agonists are just better at glycemic control? Well,
this was the point of the second paper that I showed, where they did a head-to-head comparison between sort of variety of second-line treatments. And as far as I'm aware of the diabetes literature, there's no particular evidence that GLP-1s are better than all the other ones in terms of how good of a control they achieve peripherally. Now there is a question of perhaps how effective these compounds are at crossing the blood-brain barrier. There is good evidence that GLP-1s do this very effectively. So perhaps it goes back to this potential differentiation between central and peripheral insulin resistance, and that actually it's the fact that GLP-1s are able to modulate insulin resistance in the brain, while for some of the other second-line treatments, that isn't the case. That will be my interpretation, but I wonder what you think, Masud.
Well, no, I just think it's one of those confounds that's really important, isn't it? Because you showed us the other kind of confounds that were looked at, but one thing that wasn't there was something like glycosylated hemoglobin level.
Sure.
You kind of think, well, that's a very important measure to show us that there was no difference between those different compounds in terms of their control over the diabetes.
Yeah. Well, I mean, I guess these studies are very powerful in that they come from large epidemiological samples. So one was, both of these are Danish registers and so on. So they are limited in how much of this sort of, diabetes control they can demonstrate. All we can rely is perhaps the indirect comparisons that we can make on the basis of the primary studies, which show that all of them are effective enough in order to be granted approval to be prescribed for diabetes second line.
Yeah, no, it'd be interesting, because you kind of also think, how did these drugs get approved? If they weren't any better, what was the reason they got approved?
Well, exactly.
We've got some questions coming in here. So Francis Seal asks, galectin-3 blocks insulin receptors, and GAL3 loss has been shown to ameliorate mouse models of Alzheimer's disease. GAL3 blockers are in clinical trials for fibrosis. I'm not sure what kind of fibrosis is that, liver fibrosis or... Anyway, what are your thoughts on trying these in type 2 diabetes and MCI?
So the I guess the mechanism here is that if they block the insulin receptors, so presumably, Francis, you mean that they are agonists, so that they have some endogenous, they stimulate the activity at the insulin receptor. If that, and potentially that is why they, as you say, they improve the mouse models of Alzheimer's disease. I guess, if there is good preclinical data, then by all means. I'm just not sure, at what stage of development, because I haven't heard of this compound before. I don't know whether you have, Masud. I certainly am not aware of it in the clinic.
Yeah.
So
maybe Francis has typed back, yes, it's about fibrosis, but I don't know, Francis, has anyone tried this in humans? Any of these? Apart from maybe the clinical trials for fibrosis have started on that. Okay, maybe Francis will come back to us. Yes, in progress with true being. Not sure what that is. Okay, maybe we can come back to that.
So, but I definitely think that, if there is good enough preclinical data, then, at least my thinking of where the efforts in repurposing should be, if that is coupled with some at least early epidemiological data, that it is helpful for people prescribed these conditions for something else.
Okay.
I think it's certainly a strong candidate. And if you know a lot about the safety of these compounds, because if you're going to be selling a sort of a repurposed trial to people who are otherwise healthy, it really only works with a medication which has a very good safety profile.
And we've got another technical question here as well, is why do you think GLP-1 has stronger associations with cognitive decline, AD, than DPP-4 inhibitors targeting both GLP-1 and GIP? Maril Rinsberg.
Yeah, I don't think we necessarily know. There may be difference in, as I say, in the penetration, in the blood-brain barrier penetration, and also the other question is, I definitely know that there is good evidence that GLP-1s affect systemic neuroinflammation. I don't know whether that's the case for the other group of medications. So, and that's certainly one of the main hypotheses that certainly Novo Nordisk are working on, is that GLP-1s are effective, are potentially changing the course of Alzheimer's disease pathophysiology through the effect of inflammation, rather than necessarily interfering with either tau or amyloid pathways. So potentially the difference may lie there.
And of course, the other thing that you've got in your trial is these are people who are not diabetic, right?
Well, they could be diabetic, but we've capped it at 30%. I didn't mention this, but that is, we didn't want this to be only people with diabetes.
Right. So the company wants a bigger market in terms of, seeing how this plays out in people who aren't diabetic.
Well, I guess that will be sort of the commercial way of looking at it. But I think it's also important that we test whether this is generalizable, because we already know a lot about how these medications work in terms of potentially dementia prevention in diabetics. But it is an open question, right? Whether this is some sort of a diabetes specific process, whether you need to be insulin resistant to begin with in order to benefit, or whether if you give it to people who are sort of normal aging, whether you still achieve some sort of benefit. That will be an important distinction.
And please do put any other questions you have in the chat. But what that raises, Ivan, though, is the kind of sample size you need, right? If you're going to substratify in terms of whether you've got in the healthy population some kind of insulin resistance group versus a non-central insulin resistance group, that just clocks up the numbers you need. Well,
it would, but at the same time, I'd argue that, for example, because in the first set of experiments, we'll really be asking that question in type 2 diabetes. So the hypothesis is that within type 2 diabetes, obviously everyone has peripheral insulin resistance, but from the limited data that's available from intranasal administration, it seems like there is a bit of variability in terms of whether they actually have central insulin resistance or not. So certainly, I think within the type 2 diabetics, you could be talking about stratifying future risk of cognitive decline on the basis of whether they actually their brain is sensitive to insulin or not. But in the broader healthy volunteer population, I guess certainly the point of the ISUP trial is that we're saying, well, we're giving it to everyone. We don't care whether they have documented insulin resistance or not. We want to see whether it impacts on their tau accumulation, because if they start off from being amyloid positive, we already know what their tau accumulation is on an annual basis, and it's significantly higher compared to somebody that doesn't have it. And so if that's if the trial is successful, then we would certainly be talking about giving it to people who are amyloid positive.
And mechanistically, how does central insulin resistance lead to tau accumulation? What do you think? What's the proposal?
Well, the proposal is that it interferes directly with the, I won't say the GSK pathway, but I think that may be amyloid. In any case, there have been a couple of papers showing that it is involved in the actual phosphorylation pathway. So I'm sort of on slightly shaky grounds here because this was sort of very dense preclinical papers. But the implication was that it's involved in the actual pathway of phosphorylation, and there's some studies showing that if you knock out GLP-1, then you have more tau pathology, and then also if you have models where models of Alzheimer's disease that are primarily tau driven, if you treat with GLP-1s, then you have less pathology. So there's some perhaps not very direct evidence that the insulin pathway interacts with specifically with tau. And also, if you look at the biomarker work in humans, there's a much tighter relation between insulin resistance and biomarker abnormalities in tau. The amyloid story is a lot more conflicting, and it's on the sort of this large study recently that was published in Brain that showed sort of a relationship between having a diagnosis and being amyloid positive.
Okay, great. Thank you for covering that. Are there any other questions that anyone would like to pose to Ivan? This is your chance. Give you a few more seconds.
Do you have a view, Masud, about how exactly we would, what would be the trial design where, if we find, a compound for which there is a good enough signal from sort of proof of concepts, perhaps using expensive measures like tau PET or TSPO PET, or even just blood in existing samples, what would be the optimal design where, people in academia who want to test this and sort of prove that it works for preventing Alzheimer's disease, what would that look like?
Yeah, I mean, that's partly the outcome measure and also the duration you're thinking of here, right? And I think,
but also, who do you go for, sort of population-wise, right?
Yeah, well, then that's the thing about whether this would be actually effective in people who aren't diabetic or have impaired glucose control. It seems to me that the place to do this first might be within the diabetic population, right? Because you're probably more likely to get something here first and then think about whether it can generalize.
Okay. But in terms of outcome measures?
Well, outcome measures, everyone's talking about this, is whether you should be using, the standard outcome measures, which are not very sensitive necessarily. So the question is whether these digital cognitive measures performed remotely will give you not only more sensitive measures, but because you can do them more frequently, you can be powered up to look for changes more robustly than in the usual way where someone comes every 3 months to have a cognitive test face-to-face. So I think that is an unanswered question. People are beginning to suggest that even phospho-tau, plasma phospho-tau, might be an interesting measure. Up to now, that has not been the case, that it's only of diagnostic value rather than of monitoring disease progression. But Cornelia, who's here as well, and I were in Amsterdam this week. I'm beginning to think that there and in Sweden, people are considering phospho-tau as a potential disease progression monitor as well. Yep.
Yeah, because certainly on at the Alzheimer's disease conferences, you hear that NFL is the one that really is the sensitive measure of what's currently going on. So it's the primary efficacy. Well, the p-tau, as you were saying, it's are you at risk or not, and then they don't expect variations. But you're saying thinking has changed.
This is evolving, and also the idea of multiplexed outcome measures that you use a composite might be one other way to go, including cognitive or plasma biomarkers in addition. Yeah. Okay, I think we haven't got any further questions in the chat. So thank you all for attending, and thanks also to Ivan for presenting us with this new approach to thinking about how to treat cognitive impairment and dementia. Thanks, Ivan.
Thanks, Masud. Cheers. Bye-bye.